Rapid production of SpaceX Raptor engine is mind-blowing. Keep in mind that the Starship is a two-staged rocket. The first stage Starship, known as the spaceship itself, is propelled by 3 sea-level and 3 vacuum-optimized Raptor engines. The Raptor vacuum engine is designed to have a smaller engine nozzle to avoid flow separation when the engine is fired at sea-level atmospheric pressure. The first stage Starship doesn't really require a lot of thrust, since the space's atmosphere is lighter compared to the Earth's atmosphere. The Super Heavy rocket, on the other hand, which is the second stage of the Starship, operates in a totally different manner. SpaceX has developed the booster and stacked it with about 30 to 33 sea-level Raptor engines, all installed under the booster. The booster needs as many engines as these to be able to have the required thrust, which will enable it to pierce through the Earth's thick atmosphere and overcome gravitational push, acting in the opposite direction to the rocket's motion, before it'll separate itself from the first stage Starship, and the first stage Starship will take over and continue the journey in space. So, each Starship on the whole needs about 39 Raptor engines for it to go into space. Hence, SpaceX has devised an insane method to rapidly produce about 800 to 1,000 Raptor engines every year. This is TechSpace. If you're new here, we especially invite you to join many of our lovely fans. Kindly subscribe and click on the notification bell. It motivates us to produce more fantastic content like this, and you'll have a lifetime access to all of our high-end tech videos. Don't forget that SpaceX is preparing to meet up the right launch cycle, that is, and occasion Earth and Mars will be so close. This time, it will only take 5 months for SpaceX to launch about 100 Starships on Mars instead of 7 months. Therefore, SpaceX has to be very fast to develop whatever the Starship will need for a successful mission to Mars before the launch cycle gets closer. And that's also another crucial reason why SpaceX will need to be fast about producing the Raptor engine. If one Starship needs about 39 Raptor engines to get into space, it means that SpaceX will need to manufacture about 31,200 Raptor engines each year to meet up the goal of manufacturing 800 working Starships each year. And that will definitely be a nightmare for the company during the production season. According to Musk's presentation to the National Academies of Sciences a few months ago, the company hopes to conduct the first orbital launch of Starship in early 2022. However, in order to keep the company serious and determined in the space business, SpaceX needs to launch Starship at least once every 2 weeks. Musk once stated dishearteningly that after key senior management left the company, SpaceX personnel dug deeper into Raptor production issues and discovered them to be far more severe than was reported. We can never tell that's part of the reason why these guys left the office, but these guys were actually a bone of contention on the development project about the Raptor engine. It took the company about 16 months of additional construction to prepare the site for an orbital launch pad. This includes a launch table for the Super Heavy, a launch tower that will lift the Starship onto the Super Heavy and hold the giant rocket in place before ignition, and a tank farm containing fuel and other liquids that will be pumped into the rocket prior to launch. The tower has also been outfitted with a massive pair of arms known as Mechazilla. They will literally catch the returning Super Heavy rocket and stabilize it as it softly lands on the pad. Regardless of whether Musk plans to incorporate a city close to the launch site or given the go-ahead, Starbase is undoubtedly set to become one of the most important launch sites on Earth. This is because it is from here that the spacecraft that will return astronauts to the moon will be launched. Now let's take a look at the working principles or the functioning mystery behind the SpaceX Raptor engine. Rocket engines generate enormous amounts of energy. When the propellant within the engine burns, it transforms into gas and produces huge pressure inside the chamber. Each engine is typically tested independently at SpaceX's McGregor, Texas plant before being delivered to Boca Chica. The engines are then connected to Starship prototypes and subjected to a series of static fires or even flights. However, in order to finish the orbital mission, they will need to rely on an untested engine, which is the Raptor vacuum engine. The nozzle, on the other hand, is a critical component of the engine. This is the engine's last stage, and its function is to send all of that pressure out the rear to optimize thrust. To make the most use of that pressure, the nozzle is built such that the pressure of the gas as it exits the nozzle matches the pressure of the surrounding air. If the pressure at this point is greater than the ambient pressure, it will overflow the sides, limiting thrust. This does not harm the engine, but it does lower its efficiency. When rockets ascend through the atmosphere, the air pressure reduces. This means that regardless of how the nozzle is formed, the engine will lose efficiency as it rises in altitude. However, because the Starship's second stage isn't used until it is already out of the thickest parts of the Earth's atmosphere, its main engines can be specifically designed for the vacuum of space. The Raptor vacuum engine features a substantially bigger engine nozzle to perform efficiently in space. Because there is no atmosphere to push against the exhaust plume in space, it expands significantly more. The issue arises when it comes time to put this type of engine to the test on the ground. Although it is okay for the exit pressure to be more than the ambient pressure, the consequences might be disastrous if the exit pressure is significantly lower. When this occurs, air begins to make its way into the engine bell, separating the exhaust flow from the nozzle walls. If the pressure differential is too great, the engine nozzle may shake so violently that it tears apart. Because the Space Shuttle's engines had to function from the ground all the way into space, this was a difficulty they had to avoid whilst constructing it. In order to get around this, the nozzle was designed as an in-between, so it could operate in space and at sea level without braking. Before the engines reached full power, the outside air pressure would push its way into the nozzle, causing the nozzle to bend due to flow separation. Although this appears to be a risk, the flow separation was never strong enough to harm the engine. NASA, on the other hand, had to get more imaginative in order to test suitable vacuum engines. The Plum Brook testing facility is located at a NASA site in Ohio. This is a massive test chamber in which the air is sucked out until the pressure practically mimics a full vacuum. When the engine fires, a steam ejector mechanism condenses and extracts the engine exhaust from the chamber whilst preserving the vacuum. SpaceX does not use anything like this. In fact, to test the vacuum version of their Merlin engine, they removed the nozzle entirely because testing it with the nozzle at sea level would inevitably rip it apart. The Raptor engine, on the other hand, has a much stronger nozzle. The key difference is that they can operate the engine at significantly greater chamber pressures. This implies that even as the exhaust exits the end of the nozzle, the pressure remains greater than the surrounding air, preventing ambient air from entering and causing flow separation. This is a significant benefit since SpaceX can thoroughly test the engine without depending on just computer models. With more and more parts of the Starship architecture falling into place, SpaceX will soon be able to undertake a full orbital voyage. Until then, we might marvel at the huge amount of engineering that has gone into Starship, the vessel that will one day transport humanity to another planet. To get to this stage, SpaceX has to employ the best brains in the country to work on the Starship's development. You know, this is a really complex engine, so it won't require any blunders, and because it will be transporting humans across a great distance in space, it isn't expected to develop any faults and eventually cause casualties during liftoff. There are other methods to learn about tech on the internet, but here we create a brilliant family that teaches you to think critically about a problem and genuinely comprehend it as one of a kind. If you like this video, you're probably interested in things like space, physics, math, and engineering. In that case, you are a brilliant friend, and people like you are mostly curious about technology and how it works, also interested in creativity, design, and fabrication. Let's officially welcome you to our family, TechSpace. Hit the subscribe button to be in line with our updates, and also check on us anytime you feel like.